My first example is going to be a fraction. Now, I can't do direct substitution. Why not? Because I would get 2 squared, which is 4 minus 4. I would get 0 over 0, which is a big, big, big no-no. Now remember, I don't really care what's going on at 2. Actually, there's a hole in the graph, but I want to know what we're approaching. So what we can do is to simplify this. So I'm going to factor. I'm going to rewrite this as the limit as x approaches 2 of, and this would be x plus 2 times x minus 2 over x minus 2. Now I could simplify this fraction by dividing out the common factors as long as x is not equal to 2. But we're not looking for when x is 2, we're looking for when x approaches 2, so I can simplify it. So this is going to turn into the limit as x approaches 2 of x plus 2, because I can divide out, quote, quote, the x minus 2's. Now I can do direct substitution. 2 in for x gives me a 4. Let's do another one where we have to use factoring. This is a great one because I like to review factoring because even though we've been doing it forever, we always forget how to factor. Whoops, I meant to have that parentheses around everything. X squared minus 2x minus 8. Okay, if I plug in 4 right now, I'll go ahead and tell you I'm going to get 0 over 0, which is bad news. So I'm going to go ahead and factor. And I keep putting the parentheses around these, but you don't really have to have it there. So let's review how we would factor the numerator and how we would factor the denominator. Well, this would have to be x and x. Multiplies to be 4, but adds to be a negative 5 would have to be a negative 4 and a negative 1. Down here I'd have an x and an x. Multiplies to be negative 8, but adds to be negative 2, means I'll have a negative 4 plus 2. Notice that the x minus 4's could divide out as long as x is not 4. So this is equivalent to having the limit as x approaches 4 of just what's remaining. So these kind of divide out, and I'm left with x minus 1 over x plus 2, and now I can do my direct substitution. 4 in for x gives me a 3 in the numerator and a 6 in the denominator, and that reduces to 1/2. Now sometimes it's not that I have to factor, but that I have to actually simplify. So I'm going to label these as factor. And this next one I'm going to label as simplify. So let's say I had, this is a good one, the limit as h approaches 0 of h plus 4 squared minus 16 over h. Now what would happen if I plugged in 0 right now? Well, I'd have 4 squared minus 16, that's 0, over 0. That's a no-no. But this one I can't really factor. So what I'm going to do is simplify. So I've got to remember how to square h plus 4. So that really means I'm going to have h plus 4 times h plus 4. So I will show that. And then I'm going to have to go to the next line. H plus 4 times h plus 4 is going to give me h times h, which is h squared. I'd have 4h and 4h, that's 8h. And then plus 4 times 4 is 16. Then there's this minus 16 that's still at the end over h. Now, notice I have a 16 minus a 16. So I'm going to be left with h squared plus 8h over h in the denominator. Well, they both have an h in them, so I can factor out that h. Now, what happens to the h's? Now they can divide out. So I kind of went back and became a factoring problem after I simplified a little bit. And now there's no danger of doing a direct substitution. When I plug in 0 for h, I'm going to get 8. The next one we're going to look at is with some square roots in it. And these can get a little tricky. So the limit as x approaches 0, I don't know why I'm picking something with 0, but it's okay, of the square root of x plus 5 minus the square root of 5 over x. I'm going to do a couple of these because I really feel like these need some extra love. So this one, it's a little bit harder to simplify right off the bat. So if you remember back in algebra that you would multiply by the conjugate if you had a square root in the denominator. First of all, can I do direct substitution? I forgot to test that. 0 plus 5 leaves me with the square root of 5. No, 0 is not a good number. Instead of rationalizing the denominator, we're going to rationalize the numerator. So this is called rationalize the numerator. And that means I'm going to have to multiply the numerator and the denominator by the same thing because we want to multiply by a version of 0. I'm going to multiply the numerator and denominator by the conjugate. So the conjugate of the square root of x plus 5 minus the square root of 5 is the square root of x plus 5 plus the square root of 5. Everything else stays the same, but the minus turns into a plus. Now I'm multiplying by a version of 1, so I have to have the same on the numerator and the denominator. Now I'm going to put a whole bunch of parentheses in here because I got to do some distributing, which is the technical term for it. And I'm going to try to work this out really slowly so I don't lose anybody. When we distribute, I'm going to have this times this. Now what happens when I have a square root times itself? Square root times itself. I'm just going to get x plus 5. Then I have the square root of x plus 5 times positive square root of 5. So I'm going to have positive square root of 5 times the square root of x plus 5. Then now I'm distributing the inner. So negative square root of 5 times that gives me negative square root of 5 times the square root of x plus 5 minus, because it's a negative times a positive, square root of 5 times square root of 5, which is square root of 25. My suggestion on these is do not distribute the denominator. Leave it. I'm going to simplify the numerator. So this and this are the same, so they cancel. This is really just 5, so that's really minus 5. So I have x plus 5 minus 5. That's really just going to leave me an x in the numerator. Now, do you see why I said don't distribute in the denominator? I have an x, and I have an x, and they can divide out. Now, when I divide out the x in the numerator, I'm still going to have a 1 there because x divided by x leaves me a 1 over square root of x plus 5 plus the square root of 5. Now I'm going to do direct substitution. That's going to give me 1 over, when I plug in 0 for x, that's going to give me a square root of 5 plus another square root of 5. That's 1 over 2 square roots of 5. Now this is a perfectly correct answer, but on a lot of systems, they don't accept a square root in the denominator. So how do I get rid of the square root of 5 in the denominator? I multiply the numerator and the denominator by the square root of 5. And so I'll have square root of 5 in the top. And that's just going to leave me with a 5 times 2, that's a 10. This is the preferred answer. This answer is correct, but not the preferred answer.